Now we are going to start with the exponential systems. These are very different from the previous ones because of what we're going to see now. Okay, this is an exponential system, and look at this. We have here this rope that it starts here, and look where it ends. It ends here, so we need other ropes to finish the system. So we have here another one, and we have here another one. So 3 ropes. In the other system we only had 1 rope. So this makes the forces very different. First of all, let's analyze the direction of the rotation in its pulley. Let's start with this one. We are pulling from this rope, so the rotation goes this way. Now we are pulling from this rope, and this is going to move that way. And same here, we're pulling from here, and this move that way, and same here, the same here. Okay, now let's see where are the fixed and movable pulleys. This is very easy because we can see that the only pulley that is fixed to the roof with this part of the system is this one. And the other ones are movable. They are attached to the roof and to the other pulleys with the rope, so they will move up. So movable, movable, and movable. So 3 movable pulleys. And now, in order to see the equations and the formulas, I'm going to move to another application to explain it. Here. Okay, so yes, we've said that here we have the resistance, and here we have the force. We're going to name it F1, okay? F1. And now I want you to take a look at the other forces that are in the middle of the system. So, for example, in this pulley, we have here the resistance, but the force that makes this move up is this one. Okay. Same here, this force in this rope, and same here. So I'm going to name them. If this is F1, I want this to be F2. This is going to be F3 and F4. The length of the arrows are not proportional to their intensity, okay? It's just to let you know where they are. Okay, so let's see what happens here. Let's start with this one. Okay, so this is a movable pulley. Imagine that this doesn't exist. Let's see if I can cover this. Okay, so yes, we have here a movable pulley. Okay, on the usual one. So let's see what we have to do. In this case, we know that F4 is going to be reduced at the half. So it's going to be the resistance, this resistance, divided by 2. Okay? So that's it. We know now the force of F4. Let's see F3. F3 have to pull this system And the tension that has here is F4. So what do we have here? What do we have now? That F3 is going to be F4 divided by 2, because this is again a movable pulley. And what is F4? F4 is R divided by 2, so R divided by 2, which is this, and all of X divided by 2. So we can write this way. R divided by 2 times 2. Okay, we leave it that way. Now let's see the other one, which is F2. You're going to see it here, this way. This way. Yes, we want to analyze this one. Okay, another movable pulley. So the same. F2 is going to be F3 divided by 2. And what is F3? F3 is this. So R divided by 2 times 2 divided by 2, which is R divided by 2 times 2 times 2. I'm sorry for the dots and on my writing. It's a bit more difficult than writing in the whiteboard in class. Okay, so we only need this final pulley, okay? This final pulley is a fixed pulley, and as you know, the force that is made here, is the same that is made here. So the force doesn't change. So in this case, we have that F1 it's equal to F2. And F2 is this. R divided by 2 times 2 times 2. And we can express this way. R divided to 2 to the third power. And you can see that we have taken this number from where? From this. 1, 2, and 3 movable pulleys. This is what we've called N. Here, N is 3. And this leaves us to the equation here. We're going to see it here. That's what we have. The final force here is equal to the resistance divided by 2 to the nth power. And n is the number of movable pulleys, which are the ones that reduces that reduce the force. And this is the distance, okay? We've taken it from the equation. And that's it. Those are the exponential systems.